This is video number 2 for sections 9.5 and 9.6, more examples of square root equations. We're just going to continue solving a few more equations. You'll notice over here that I've made some adjustments to our how-to list, and I'll point out some of those things as we go along here. But let's tackle this the same way we were doing before. Step 1, when you've got an equation that has a radical in it, you need to get that radical by itself. Everything else is junk. In this first example, it looks like just this x sitting over here is my junk, so I'll go ahead and add x to both sides. And now that the radical is by itself, I can go on to step 2. Step 2 is that key step, right? Square both sides, emphasis on the word sides. Why am I doing that? Because squaring a square root wipes it out. If I square the left side, though, I need to square the right side as well. Remember, giant parentheses with a squared on the outside. And I think if you look carefully, you can see now why I've been emphasizing the word sides. The left is very simple. When you square a square root, it simply makes the square root go away. So that's easy enough. But it's the right side where you could easily make a mistake. The step 2 does not say square each piece. I'm not going to square this x and square this 2. That's incorrect. I have to square the entire side. And the thing is, exponents do not distribute to addition problems. What does it mean to square x plus 2? Well, let me kind of go off on the side, do a little scratch work. It means multiply it by itself. And as soon as I write that down, I'm sure your brain is telling you this is a FOIL problem, and that's exactly correct. I'm going to have to go ahead and do my whole FOIL thing and combine my like terms, and the answer that I get to that, that's what goes over here on this right side. So my right side becomes x squared plus 4x plus 4. I have no choice. I have to square the entire side. Again, make sure and pay attention to that. All right, then we move on to step 3. The radical's gone. Then I just have to regroup and say, okay, where do I go from here? How do I solve this resulting equation? Well, in the examples in the last video, we were left with just a simple linear equation. In this case, however, you can see the x squared. We've got a quadratic. This same thing happened to us in chapter 8. Sometimes you end up with a linear, sometimes you end up with a quadratic. Whichever way you go, that tells you where to go next. If you see quadratic, your brain has to start thinking factoring method, square root method, or quadratic formula. I have way too many x's showing for the square root method, so I'll go with one of the other two, which means my next step is to get a 0 on one side. I would definitely pick moving everything here over to the right because I want to keep my coefficient of my x squared positive. And then I need to decide, am I going to use factoring method or the quadratic formula? As I've mentioned before, I would certainly encourage you to give the factoring method a try. If it doesn't work, you can always go to the formula as a final option. Let's see, in this case, I don't see a GCF. I've got 3 terms. The numbers look so simple. What else could the front be except x times x? The only way to make a 2 at the back would be a 2 and a 1. Can I make a 3 in the middle? Absolutely. I think if I just plus everybody, I'm good. 2x plus 1x, there's my 3x. Easy factoring. Then I can move on to the zero product principle. Set each piece equal to 0, and then obviously I've got 2 simple solutions here, x equals -2 or x equals -1. Now remember, these are just candidate answers at the moment. Step 4, just as we saw last time, you have to run a full check on these answers to determine whether they work or not. And until I do that, I really don't know whether or not these are the answers. I'm going to have to run 2 full checks this time. Let's go off on the side somewhere. I just need to copy down the original equation. Make sure you're using the original equation. And let's first fill in -2 for the x. And then we just need to start working it out. I think I can do this by hand. That's just a 0 inside that square root. This becomes +2. The square root of 0 is 0. 0 plus 2 is certainly 2. So that guy checks out. That worked just fine. Then I'll need to do the same thing to check the other equation. So I'll change colors here. Let's recopy the equation down again, and this time we'll stick -1 in for x. Again, we'll start working it out. Let's see, inside the square root looks like a 1. This becomes +1. The square root of 1 is 1, and 1 plus 1 certainly is 2, so that one checks out as well. Since they both checked out, it means I have two solutions to this problem, x equals -2 and x equals -1. All right, let's go down now to example D, and you can see there in example D, we definitely have something new going on. This is the first one of these that we've done where there are two different radicals in the equation. Let's look back at our list of steps and I'll show you how you're going to deal with this. Unfortunately, you can only get rid of one radical at a time. So these are longer problems. What you're going to do is you're going to go ahead, you're going to get one of the radicals by itself, you're going to square both sides, that'll rid you of one of the radicals, but then you have to start over again. And you have to repeat this process, isolating any other radical, squaring both sides. You're in this loop until there are no more radicals, and then you can finish off as we did before. With that in mind, let's go down to the example. I'm to start by isolating one of the radicals. It doesn't really matter which one. Personally, I usually start with the yuckier looking one. Whichever one looks messier, I figure let me try to get rid of that one first. So to me, that's this first radical here. I'm going to try to get that guy by itself. Well, that means the junk would be the other radical. So I'm going to have to begin this problem by subtracting square root of x from both sides. Now that one of my radicals is isolated, I can go to that step 2, which is square both sides. Again, sides being so important to emphasize. Do not square the 3. Do not square the root x. You have to square this entire side, and you have to square this entire side. On the right side, I get something very easy because squaring a square root simply makes the square root disappear. On the left side, I have quite a mess. I think I'm going to have to do some scratch work for this one. I need to square this subtraction problem. Exponents do not distribute to subtraction, so I have to set this up as a FOIL problem once again. And I'm going to have to FOIL this thing out. So let's see, 3 times 3, 9. The outer would be, remember the outside stuff stays on the outside and the inside stuff stays on the inside, so I think I'm getting -3 root x, and then another -3 root x for the inside multiplication. And then the back one, let's see, a negative times a negative is a positive. When you multiply a square root times itself, that's like squaring it. It's just going to make the square root go away. I guess another way you could think of that is the square root of x times the square root of x is the square root of x squared, which is x. If you combine your like terms, your two middle guys here are like terms, you end up with 9 minus 6 root x plus x. All right, so on the plus side, we've gotten rid of one of the radicals. That's good. On the negative side, we still have one left. And so what I have to do now is I have to start this problem all over again. My next order of business is to get rid of this radical. Well, the only way I can do that is by isolating it and then squaring both sides. Well, I have a lot of junk over here if I'm going to isolate this. I have a couple of terms, first off, that I would have to move, like the 9 and the x. And then I have the coefficient here sitting in front of the radical. Now, we've been saying it's okay if you want to leave the coefficient. And I'm on the fence. I think I'm going to go ahead and divide it. I know that makes a fraction, but it makes a pretty nice fraction. And I kind of want to get rid of all these negative signs anyway. So after I divide by that -6, I have square root of x equals 1/2. Now that the radical is by itself, I can move on to step 2, square both sides. This is the second time we've used step 2 in this problem. So I need to square the left side, and I need to square the right side. On the left, square root of x times square root of x is just x, right? When I square a square root, it simply makes the square root go away. And on the right, 1/2 times 1/2 would be equal to 1/4. Step 3 is solve the resulting equation. I got off easy this time. This equation is already solved. So here is my candidate answer, x equals 1/4. We've been through a lot already, but in order for me to know whether or not this is actually the solution, remember I have to run that full check. And so my final step here, I'm going to have to take that original equation and fill in 1/4. I think I would probably, since it's kind of messy, fill in 0.25, right? 1/4 is the same thing as 0.25, and just use the calculator. So let's go ahead and fill that in. And then with the decimals, I think I would just use the calculator. If you type in this right side into your calculator, you will get 3, which means, of course, it worked. I got a true statement, and that tells me that x equals 1/4 is, in fact, the solution to this equation. Remember, you can only get rid of one radical at a time, and so the key is isolate one of them, square both sides, and then do that process over and over until there aren't any radicals